Hello, Precalculus. Let's talk about Chapter 2. We are done with Chapter 2, and this is going to serve as the overview and to put everything that we have seen in one spot. Now we are going to have a review for the exam. And we also have chapters 3 and 7 that we need to talk about. Well, 7 has only, I think, 2 or 3 sections. So I think we have 7 or 8 sections, 8 sections. And we are done with the course. So let's talk about chapter 2. See what are all of the cool things we have seen. And hopefully exam next week at some point, so we can put the chapter 2 behind us and start working on chapter 3, because it is important to cover everything before we hit the time for exam 3 and final. I think final is the second week of May. So it's coming up. Alright, so what are all the cool things we have seen in chapter 2 so far? Well, in 2.1, we have seen complex numbers, and those were z equals a plus bi, where a and b are real numbers. I was square root of -1, and complex numbers are two-dimensional numbers, right? You have a real dimension, imaginary dimension, and those numbers were used as a root, right? We had complex conjugate pairs for roots for polynomials of various degrees, and we need to know just basics, right, for complex numbers, like I is the square root of -1, I squared is -1. We need to know to add and subtract two complex numbers, and we do that by working on reals, right? We put the real values together, so that will be a plus minus c plus, and then we have b plus minus d I. So addition and subtraction was just done by adding what you call it like terms, right? It's not like terms, it's actually what we have, real and imaginary. And now to multiply them, right, we would what you would say you would FOIL. So this is times, and then you have c plus di. We would FOIL, we would get ac plus ADI plus BCI plus BDI squared, and then we fix this. We remember that I squared is -1, right? So this I squared over here, so I'll put it in blue here, that I squared is -1, so that contributes to AC minus BD is our real part, and then AD plus BCI is the imaginary part. So we do the FOILing and we're done, right? That's the multiplication. Squaring would just be, right, if you have to square complex number, well, what you do is you just multiply and follow multiplication, right? So FOIL, and you will get what we have up there. And finally, if you're dividing two complex numbers, you would multiply by the complex conjugate, and you have, right, two multiplications to deal with. So I'll just put FOIL on top, and in denominator you have c squared plus d squared. That's always the case because the middle terms will always cancel. So the next part, and that's pretty much what we need to know for complex. You can be all, cute and fancy with the graphing complex numbers, right, on the real and imaginary axis. It's somewhere here, right, and so on. All of those things. But we don't need much with complex numbers, other than know that the complex, let me actually put these as bullet points. So there's a bullet point, there's a bullet point, another bullet point, another bullet point, right here, and the one we care about also, complex conjugate. So it's z equals a plus bi, then the complex conjugate is z bar. So let's put it like if, then z equals a minus bi. So when you change your sign in the middle. So we have, yep, that's it. So we have, that's for complex numbers. And the question on the test, what can we have? We can have a value where you add them, divide them, multiply, square, and asking about the complex conjugate. Very, very simple stuff. We only just need to know it because of the next, right, next few sections in which we actually have complex roots and complex numbers be the part of what we are calculating. So now we go to the next section, 2.2, on quadratic functions. So these are actually polynomials that have x squared. And we know two forms, right? We know f of x equals ax squared plus bx plus c, from where you can use x equals negative b plus minus square root of b squared minus 4ac divided by 2a formula, because you have a, b, and c given. But you can't do much more. I mean, you can still find the vertex from this form and all other stuff, but it's just too much work. It's just too much work. Way better formula for pretty much everything else, including graphing, is the standard form of f of x equals a x minus h squared plus k. Now this is the formula we love, because we can go and say this a can be less than 0, opens down, and a could be larger than 0, opens up. So this a is amazing. And then we also have h and a k, which is h comma k, which gives us the vertex, which is the minimum or the maximum point, depending which way the graph looks like, right? If it opens up, it has a minimum. If it opens down, then it has a maximum. Good. Then the next one. We also have the line of symmetry. So x equals h is the line of symmetry. So that's another one of these. And technically, I think that is it for 2.2. There is nothing else. Two forms, and we have the few of these formulas. That's it. I don't think there is anything else that we need to worry about here. Now, there are a lot of cool things that we could worry about, like completing the square, going from one form to another and so on. I mean, that's all arithmetic stuff, things that are, important. But technically what we were learning is we learned this, right? That was the big point. All right, then we moved to 2.3, and we talked about polynomials and their graphs. Now this one was about what? This one is about polynomials of any degree. Any degree. So we said that polynomial p of x, you can also call it f of x, would be a0 plus a1x plus a2x squared plus a3x cubed plus dot 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 plus an minus 1 x to the n minus 1 plus an x to the n. So this was the formula for polynomials. Nice, there we go. And we said that the one with the highest degree is the leading term. So I need blue. There we go. Highest degree is the leading term. So now, when I write this an x to the n as a leading term, you can have x cubed, you can have x to the 7, right? Whatever it happens to be. We have the exponent to give us the shape, and an, right, whether it's positive or negative, to tell us which way, right, opens up, opens down, and stuff like that, just like we did for a quadratic one. So this is what gave birth to that 4 cases, and we're going to do the, oops, these are not graph. Sorry, these are 4K. It's bad. Let's do it better. I'm gonna do this. So let's do the proper chart. Make a big window, divide it, and they say an less than 0, an more than 0, and odd, and even. There we go. So we have a couple of these. So we know that this is called the leading term test, also known as the end behavior. So leading term test or end behavior. So we have for odd n, we have n's that would go apart, and they would be taking these types of positions. And then there is a function in between doing something, right? We don't know what is going on. So the next part is what happens for the even ones. Even one, it's opening down, and over here opens up with stuff happening in between. So that's our problem. And if the problem can be factored, woohoo! In that case, we have more information on what to draw and how to draw. So leading term test, also known as that behavior, is a very useful, very helpful thing for us to sketch the graph of the function. And that's it for 2.3, believe it or not. Learn what the polynomial function is, then the leading term test, so you can graph it. Now we do have multiplicities, we do have factoring from algebra, we have all of that stuff, but again, these things all come up when you start solving. We are reviewing first theory, and then we'll do a whole bunch of examples. Maybe I can talk about multiplicity. So I'll write here multiplicity of the root is the same as the exponent of the factor. So hopefully that makes sense, because you can have a factor x minus c, and for that one multiplicity is 1. If you have x minus c squared, well, then multiplicity is 2, right, for root x equals c, or for the root x equals c, and so on. So, and it goes like that. So exponent always matches the multiplicity. So we'll do examples. We're just going to pile up the whole chapter 2 first. Then we had 2.4, which was division of polynomials. And in division of those polynomials, we also had those two theorems that were very important. So division of polynomials plus synthetic division plus remainder and factor theorems. All of that stuff in 2.4. So we have, let's see, we have two of these. We have division of, or regular division of polynomials. So let's say you have x plus 3, this is an example, well, such is life, into x cubed plus 6x squared plus 2x minus 1. And you can also do this as a synthetic division as root is negative 3, right? Because if it's x plus 3, when you set it equal to 0, you get negative 3. And then coefficients are 1, 6, 2, and negative 1. Now, we'll do examples later. I just wanted to make sure what we have over here. So you drop 1 down, and then we get negative 3. So this gives us a 3. That gives us negative 9. So that's negative 7. and then positive 21, remainder 20, right? So I know that the answer that we are getting here is x squared plus 3x minus 7 plus 20 over x plus 3. So that's the answer. Now, synthetic division works only if this is linear. So if you have any x squares or x cubed or anything like that, it doesn't, synthetic division doesn't work. So we need to know long division of polynomials. It will pop up again in the next section, in the last section, 2.6. And then obviously it's going to pop up later in, the following math courses. So it's important to know. I'll just put 3 dots here. Now, for the two theorems, right? For the two theorems that we're interested in, those two theorems are the ones that are helping us factor and know what the roots are and all of these kind of things. So these theorems were setting up stage for the next lecture. So the remainder theorem, I'll just put R, said that if the polynomial f of x is divided by x minus c, then the remainder is f of c. So if f of x is divided by there we go, x minus c, then the remainder is f of c. So this one helps a lot with calculations in the next lecture, because we just go through and see which one gives a 0, and whatever gives 0, that's the root. We can do synthetic division from that point on. And the factor theorem had 2 parts. Part A said if f of c equals to 0, which means remainder is 0, then x minus c is a factor of f of x. And second part B, if x minus c is a factor, then f of c equals 0. Now there is an easy way to put these two together, but that's okay. So technically what this says is, if it divides evenly, there's no remainder, right? Then we call that one a factor. If there is a remainder, it's not a factor. So factor has to divide it evenly, right? You cannot have any remainder left. I think that's it for 2.4. And then we're going to take a 2.5 when we are talking about zeros of polynomial functions. So that's, come on, tablet. There we go. Zeros, and this is where we do the prs, if you remember the prs, right? So possible, the plague, possible rational zeros, also known as prs in my case. It's going to be factors of a0 divided by factors of an. Now, if you still haven't learned a formula, which you were supposed to, you see that a0 is the constant term, and an is the leading term. Now remember, an can never be 0, right? Because an is, if an is 0, that kills the leading term, and then you don't have the polynomial of that order anymore. So an can never be 0, and that's why an is always in denominator, right? It's better to know the reasons and stuff rather than just, try to memorize everything. So since an can never be 0, because that would kill the order of the polynomial, then an is the one that it's in denominator. A0 is the constant term. So this is constant term. And this one is the leading coefficient. Oops. So we go through pairs, that gives us the list, then we check the list, right? So we come up with a list. So we have the pairs list. We check values from pairs list in f of x, looking for f of x to be 0, which means no remainder, which means at that value you have a root and a factor and so on. You want to, trim it down to the quadratic, and when you trim it down to quadratic, you can use quadratic formula to find the last two roots. So all of that good stuff. I think, Descartes' rule of signs. There was so there were a couple of these rules, but I just gave you the first one, right? And technically, the number of sign changes is equal to the number or less of the roots that you might have. Positive roots. So the number of positive real zeros are also known as roots, is either the same or less than the number of sign changes. So the number of sign changes, so you literally count how many times you had, positive term switch to negative or negative term switch to positive as you move from term to term. So once you do that, it will tell you how many sign changes you have, and then you just you say, okay, so number of positive roots is so and so, and or less, right? So you can have, if you had 3 sign changes, then the number of roots, positive roots that you have, is going to be either 0 or 1 or 2 or 3, right? Because you are allowed to have the same or less. So if you come up with 3 sign changes, then that means that you have 3 or less positive real roots. Now we also want to remember, when we start factoring this and working on this stuff, that the roots are often complex, right? So that's also something that it's important, because you might trim your polynomial using synthetic division with the roots that you found, you can trim it down to the quadratic, and then you do quadratic, you get complex, and you know what to do. Well, the two complex conjugate values that you got, those are actually also roots, right? So complex roots. All right. So the last one is 2.6. This is what we did 2 days ago on rational functions and their graphs. And what I'm thinking is to just go through the basic one, 1 over x. You know, write some rules down, and then we can just go and look at some examples. Now, this was more to wrap up. What are you guys thinking about having the exam next Wednesday and Thursday? That's the question, right? So think about these things. Let's go talk about rational functions. So rational function, f of x, is when you divide two polynomials. So we divide two polynomials and we get rational function. So now the cheapest case, right, was 1 over x. And we pretty much see all of the features. We see a vertical asymptote. We also see the blue horizontal asymptote. We know that the graph is supposed to follow those asymptotes. And then we have the whole talk about, right? We can have the whole talk about these asymptotes. So we'll deal with that. We have to follow this, and in this case we don't have the x and y intercepts, but if you move it you will, and all of that good stuff. Domain and range, you look for the x's that are possible, and so on. Let me see if we have anything, or it's just procedures. Yeah, so vertical asymptote. So let's go with the bullet point now. VAs cannot be crossed by a function. Horizontal asymptotes and horizontal asymptotes and slant asymptotes can be crossed, but both must be obeyed at infinities. So for vertical asymptote, before that, number one, make sure all, that's a weird way to, make sure you cancel what can be canceled. That's the first. Then we set come on, we set denominator equal to 0. So once we have denominator equal to 0, yep, denominator equal to 0, and then we have the values for VA. Solve equation and win. Haha. There you go. Horizontal asymptotes have the three rules. So we have ax to the p divided bx to the q. So if p is bigger than q, no ha. If p is equal to q, then ha is given by y equals a divided by b. So this is case 2. And finally case 3, if p is less than q, then ha, horizontal asymptote, is y equals 0. So these are the three possibilities for horizontal asymptote. And finally, slant asymptotes, sa. That is this case, actually. So if p equals q plus 1, so p is bigger than q, right? If p is bigger than q by 1, then we do long division to find, we do long division to find the slant asymptote. Please understand that the slant asymptote is y equal mx plus b, right? It's a linear line. And that's the reason why they have to be exactly 1 power off. Because when you divide x cubed with x squared, you get a single x. When you divide x to the 10 with x to the 9, you get a single x. Right? So you can have a linear line. If you have, right, if you have the thing like, let's say, x cubed divided by x, well, the difference, the quotient there is x squared. That's not a linear slant line, right? That's x squared. We don't have asymptotes that look like this, right? Your y equal mx plus b asymptote is the slanted line. So x to the first power, and that's why you are only allowed to have the first power there. All right, cool. This is what we have. So now those are the three asymptotes, and then we just compute the point, right, to figure out whether the line is above or below. So to make the decision on what do you call it? Which graph to keep and which to purge. I haven't used word purge from the beginning of the semester, so there you go. I snuck it in. So to make the decision on which graph to keep and which graph to purge, compute a value from that region. So if you remember, we had something like this, and then there was a asymptote there, and then we were wondering whether we should keep the top or the bottom line. We know we can't have both of them, right? One has to go. So we compute the value, in this case, whatever the value you pick. Let's pick x0. And this is what's happening. See, for this point, y is larger than 0. And if you pick the one, right, if the one on the bottom is right, that's y less than 0. So you are going to get either the number that is bigger than 0 or the number that is less than 0, and those two, right? And that will determine which one you keep and which one to purge. Yes, to purge. And believe it or not, that's it. In addition to this, we just, sneak in one problem from 110. This is not that much material, and some of this stuff you already knew. Complex numbers, that was even skipped in the syllabus because it was supposed to be, something you guys did in intermediate algebra. Quadratic functions, plug values, compute numbers, graph, right? So the new thing was, technically this was new, right here, that's new. The rest was also intermediate algebra. Polynomials and their graphs, you're literally learning two concepts. We move along. You learn the leading term test, and you learn multiplicities. Division of polynomials, right? If you know division algorithm for regular numbers, then you know for this one as well. Synthetic was new, and the two theorems to set up 2.5. You know what? All of these 6 sections, I would say half of it is new, and half of it, if you were really good in intermediate algebra and you honestly learned it, not just for the, the nonsense for the grade, but you actually learned it to know it, half of this stuff you already know. So this exam could be a really, really good exam for you guys. Now, in terms of the exam, I am going to have a meeting tomorrow with some of my colleagues to determine what is going on with success rates and exams and so on. I had some students that are asking questions from my other classes that had already online exams, and they're not treating it as the exam at all. Right? They say, oh, but the quizzes had infinitely many tries. Why don't we have infinitely many tries for a test? It's a test, right? Also asking for extra time because, the test is online. I don't see how's the online test any different than the in-class test. If you have hour and 20 minutes in class, hour 20 minutes online, it's the same thing. The only difference is you will be working out problems on a paper anyway. You just need to type in the answer. So how long is it going to take you to type, 15 different things or to click A, B, C, right? That can't add more than 2 or 3 minutes on the entire exam length, right? Even though the MyMATLAB test should be, in some sense, easier for everyone if you honestly did the homework, because I can't come up with anything that you haven't already seen in MyMATLAB. So the exam technically should be a joke, because you have seen all of the problems if you did the homework. If you still want to practice, you can go to study plan, which contains 100% of the problems. I said this last time. If you do and know every problem from the study plan, then you have definitely done already every problem that you can possibly get on the test. Because study plan contains 100% of the problems available in the software. They will change the numbers, 3 into 7 and 2 into -2 and so on, right? So just but everything, the statement of the problem, the function, the concepts, everything stays the same. So the numbers might change. And there is literally no difference in having the exam, other than obviously, cheating is now possible. But again, those of you who pass this course through whatever external help, you will never pass calculus. I will sign that. You will never in 1,000 lifetimes pass calculus if you don't learn these concepts. You can go to calculus, you can, you can cheat your way into A in pre-calculus, but your education is over until you retake pre-calc and learn it, or sit at home a couple of months, learn it on your own from videos and whatever, and then go take. I did tell this story once. I did help one person before to pass the test. This is while I was a student. I tutored someone to pass to beat the placement test for trig. So that person failed calculus first time, scored D second time, and then finally B+ on the third shot. So there we go, right? Now this person knew all of the Precalc1, including exponential logarithmic functions, which is, right? But guys, everything we do later, Calculus 1, Calculus 2, differential equations, it's filled with trig and exponential and logarithmic functions, and it's just a mess of things. And if you don't know those concepts, you're not getting anywhere. So cheating is technically, you are ending your own education for this. You can go, you change your major. Change your major and go into whatever other field, but you will never pass Calc 1 if you don't know pre-Calc 1 concepts. That's simple as that. Now, partial credit. There is a button that we click, obviously, and the partial credit is assigned to all of the partially correct problems, because you know that a lot of those problems are multi-layered, so they do allow partial credit moving along through the test. So if I say that you're going to have 90 minutes for the test, right? Let's say in class generally we have hour 20 or hour 25, right? Now I did promise that I'm going to add extra minute because you asked me nicely, and I'm the best person you will ever meet in your lifetime. So clearly I'm going to add extra time, so you can type those answers in peace. So if your exam is 91 minutes, let's say, right? Then you should be able to do it in that time frame. If it's now taking you longer, right, then if it takes you a long time to solve a problem, that just means one thing: you don't know it yet, right? You need to practice. You need to learn the concepts so you can move faster. If you are to go to the next course and then you still don't know pre-calc, then you have to learn calculus and you have to learn pre-calc on top of it, right? Because you won't be understanding what's happening with functions, right? Calculus operates on functions. You are learning concepts that apply to functions, and then the functions can be exponential, logarithmic, polynomial, and if you don't know some of them, well, then you can do problems in calculus. Now, you will know calculus concept, but it will be very irritating because you still can't do the problem because you don't know the pre-calc part of it, right? So it's important to sit and really grind through this. I'm open to have exam on any date. We don't even have to follow Mondays and Wednesdays. We can have the exam start on Friday, end on Saturday. We can have exam, it's not a big deal, right? Tell me when you are ready, right? On Monday, I'm going to teach 3.1. We can have review on Wednesday, and we can have exam start on Friday at noon and end on Saturday at noon. So you will still have that 91 minutes when you start, right? And if you have any accommodations or anything, that will automatically be added in my MATLAB as the accommodation for time. But there is no need to email me about that. That is automatic, right? That's in the system. So if you have the letter from the college, from the disability services, it's already in a system, and you do not have to email it or ask about that. That's already done. So keep practicing, keep doing the homework, and you want extra practice? Not a problem, right? Because the study plan in my MATLAB is available 24/7. And study plan has all of the problems and all of the concepts, all of the chapters, right? All of the sections. And they're open 24/7. So you can keep practicing. And finally, I am going to make a post in announcements in Canvas, right? And you guys can just go back and forth and, talk about the dates, right? Talk about the dates. It would be the best to have it next week, because we just finished, right? We just finished chapter 2. On Monday, I will be teaching 3.1. So do you really want to have, 3 or 4 sections of chapter 3 done and still have chapter 2? Because the problem is that you really don't start learning anything until you're done with the test. And then you're behind. And the next chapter is the most important chapter of your life. It's exponential and logarithmic functions. And everything in STEM is exponential and logarithmic functions. Everything. So if you don't know chapter 3, there is no STEM for you. Don't worry about the calculus. Calculus, right? There is no calculus, obviously. But there's no STEM, right? You can do pH values. In chemistry, you can't do them without logarithmic functions base 10. Right? You can't do that. You can't do physics. You can't do anything. So next chapter is insanely important. So what I'm saying is, having the exam as soon as possible is the best. My suggestion, actually I'm not even going to give suggestion. Just suggestion is as soon as possible. You will tell me the date, right? Now I want to keep it running from noon to noon. So if let's say you pick, I don't know, arbitrary Thursday next week, it will open on Thursday at noon. It will go through the night, open, and it will close on Friday at noon. Which means that if you start at 11:30 a.m. on Friday, your exam will automatically shut down in 30 minutes. And that's it, right? So we have, right? There is the issue with cheating for the 3-day time frame. It's a 24-hour window, and rather than having it from 12 to 12, which is what my MATLAB does, I like noon to noon, because it goes through the night. So that gives, now we can start on Friday and end on Saturday. Now I know some people work Friday, some people work Saturday, some people don't work now at all because of the situation. We can do any day. You want Wednesday, Thursday, you want Thursday, Friday, you want Friday, Saturday. I would not go Saturday, Sunday. It's possible. It's online. This class is now online. So our meeting time on Monday, Wednesday at 5:30 doesn't mean anything anymore, right? Vast majority of other students do not have any interaction like this. They just have, they're just reading words on Canvas and that's it, right? The words say do read page so and so, do homework on page so and so, and here is the MyMathLab exercises. That's for vast majority of students. That's it, right? Okay, so let's do a couple of problems here. There will be announcement in Canvas. I'm actually clicking right now to open it up, so it's open for me to remember to actually, you know what? Boom. I'm here. So announcement, topic title. What's a good topic title? Exam 2 dates, because it's today. There we go. And I'm just going to say exam will start on noon and end the next day noon. So noon to noon. What else is important for us to know? Exam will be 91 minutes long. That's it. That's all it is. So please talk about the dates. Oh, there we go. And I am fixing the issue so you can actually see what others wrote and then put. Okay, good. All right, there's the announcement. Done deal. So you can start. Again, we can literally do any days. So any days are okay. Okay? Any days are fine for me. I still have to obviously make the tests. I'm going to have some department discussions tomorrow and so on. We're learning about best practices and so on for this emergency situation. So we'll see. All right, let's go and work out some examples. I just want to multiply 3 plus 2i by 4i, right? So there we go. We have 12i plus 8i squared, which gives us negative 8 plus 12i. So this is standard problem, 2 points on the test, right? To just foil. So just keep, practicing. I squared is negative 1, so that's how we get negative 8. So we have, I see you guys are discussing this here on the chat. All of you have to keep in mind that the exam goes through the night. If you want to do it at 3:15 a.m., do it at 3:15 a.m., right? One important thing is to understand is now with the newfound freedom, we are never going to have, a time that it's perfect for everyone. Good enough is good enough. I mean, you need to be able to find hour and a half in 24 hours for the test. Now, I gave you a little bit more freedom to figure out what days work the best. Now, they're not going to work the best for everyone, but also I can just cut the discussion and say you have to be online on Wednesday at 5:30 to take the test. So 5:30 and closes at 7. We can do that, right? Because the time for the class is Wednesday at 5:30 and you're not supposed to have the work or any other class interfere with that time frame, right? 5:30 to 7. But let's just have it, so you guys can figure these things out. All right. So let's go and take a look at some other things. For instance, this is just a couple of more problems. This is not a review. This is like overview of the whole thing. We have another, say 15 minutes or so. So graph negative 3x cubed plus 6x. Oops. Why is that there? 6x minus 12. Right. So we use the leading term test, right? You're going to say, my a is negative 3, which is less than 0. My n is 3, which is odd. Right? Those are the two things I need to know. So now I just sketch the graph and I'm done. So odd means that they are going to look like this or like this. Now this is for a larger than 0. This is for a less than 0. Since we have less than 0, it's this one. So the graph will look something like this. Not exactly that, but something along those lines. It might look like this, might look like that. I mean, I don't know. Pick any. What's important is this and this part that we can do 100%. Now, much better version of these graphs is when you have factors. You can have zeros, right? The x-intercepts. So that's much better version. So say you have f of x, or graph. You have 3 x plus 1, x minus 2 squared, x plus 6, whatever. So how many roots do I have? How many zeros? Well, I have 4 because it's x is negative 1 with multiplicity 1, x is equal to 2 with multiplicity 2, and x equals negative 6 for multiplicity 1. So what should I do? Well, I can... Okay, so we see over here that a is larger than 0. And over here we see 1 plus 2 plus 1 equals 4, so exponent is even. You add that where the multiplicities are. Right? If you look at this line, you might say, oh, there are 3 roots. No, there are 4 roots. 1 plus 2 roots over here, plus 1 root there, 1 plus 2 plus 1 is 4. So it's even. So we have even and larger than 0 for A, it's going to have behavior like that. Okay, let's go and sketch this graph. Now, obviously, you'll have way better options and things when you take calculus. I did say that this will repeat this section. Well, all of the sections will repeat and will be used every class, every day. But we are actually going to have 4.4 in calculus. We're going to have 4.4 on graphing functions. And when you start graphing functions, you'll graph functions precisely. So all of this will be repeated with more details. So I have my root of -1. I have a root of -6, 2, 3, 4, 5, -6. And I have root at 2. And I have the behavior like that and the behavior like that. So connect the dots. That's what we're doing here. Connect the dots. So what do I do? Well, -6 is M1 root, which means this is going to shoot straight through. -1 is also M1 root. This means that this has to turn and then shoot straight through 1. And now I need to connect these two parts, but it also has to go through 2. Well, 2 is the, luckily, right? Not luckily, it's math. It's M2 root, and that bounces off like a quadratic. So we know that M1 roots, they shoot straight through. M2 roots, they bounce off. M3 roots, they shoot through like a quadratic, like a cubic, and so on. So this is your M1 shooting straight through, M1 shooting straight through, and M2 bouncing off. All of these pieces, they have to connect every single time, right? Now, I know you asked in class, I'm just going to mention it here. We don't know, where the peak is. We will know in calculus, but we don't know in pre-calc. So wherever you put the peak is good. Now, you'll be doing this on the screen, so, poke it. I am adding, extra time for that, for the annoyance. So you should be fine. I know that we're out of time, but I still want to do one more of these rational ones. And then, depending on what you guys discuss in the comments, Monday will either be a review for the test or it will be 3.1. Now, also, I will be opening those 7 quizzes for 7 days, right? So if you all discuss and agree to have your exam on Wednesday, let's say, then the first quiz is tomorrow. If you agree on Thursday, then the first quiz is on Friday, and so on. So I will open the quizzes as soon as I figure out, right, what is the one, a lot of you agrees upon something. And will, right, so definitely there will be a review. This over here was overview of chapter 2. All right, let's take a look at one of these problems. So I am looking at problem 80 on page 399, and it says graph f of x squared minus 4x plus 3 divided by x plus 1 squared. Okay, so I am going to start by factoring, right? I'm going to start factoring here. What do I have? this one factors as x minus 3, x minus 1, right? Yeah, and the bottom is still x plus 1 squared. Okay, nothing cancels. So let me just put this note over here. We had to check if some cancel, but nothing canceled, right? So we're just going to go with the program. We have vertical asymptote calculation, which is x plus 1 squared equal to 0, which is just x plus 1 equal to 0, which is x equals negative 1 for vertical asymptote. We have our horizontal asymptote. Powers are the same, so our horizontal asymptote is 1 divided by 1, which is 1. So y equals 1 is the horizontal asymptote. Powers are the same. Coefficient, if you FOIL this, right, in the denominator, you will get x squared as the first term. So you have x squared divided by x squared. They have the same powers, if you haven't learned this yet. So same powers mean take the ratio of front coefficients. And both coefficients are 1, so 1 divided by 1 is 1. No SAW, no slant asymptote, because we have horizontal asymptote. You can't have both of them at the same time. They are mutually exclusive. And I'm also going to find the roots, known as zeros. And that's when I set x squared minus 4x plus 3 equal to 0. We factor that into x minus 3, x minus 1 equal to 0. And we get x equals 3 and x equals 1, both m1 roots. Right? Both m1 roots. Good. Let's go. What do I have? X is negative 1. I'll use 2 squares. That's negative 1. Y, horizontal asymptote, positive 1. I have a root at 1 and root at 3. All right, so let's check this one more time. We have this, we have this, the x squared, that gives us negative 1 for the x. That's the vertical asymptote, because, okay, good. And then, all right, fine. So now, we start to do this or this, right? So those are our decisions. Well, we have to delete the one on the bottom, because look, it's creating x-intercept that we don't have. So we have to get rid of the one on the bottom. Does it make sense? I hope it does, right? So your lines are either the one on top or the one. You can't have both because they fail vertical line test. So you have to delete either the top one or the bottom one. Well, the bottom one is creating a non-existing x-intercept. We got these two to be x-intercepts. So the one is not on the list. Therefore, I am removing the bottom part, keeping only the upper part there. Now, what do I have here? Well, since these are the two intercepts and the function has to go through them, I know that the function has to come from below, go through one root, go through the other root, and eventually bounce back. But see, this is an issue now. No, this is bad, actually. Let me calculate y-intercept as well. Y-intercept will tell us. This probably is coming from above and then goes like this and probably does that. Pierces through the asymptote. So I'm looking for the y-intercept that it's larger than 0. Y-intercept, set x equal to 0. So for our problem, we have 0 squared minus 4 times 0 plus 3 divided by 0 plus 1 squared. Yep, that's 3 over 1 equals to 3. 1, 2, 3. So the function is going to go from the top down, bend back, because that has to be m1 root, that has to be m1 root, so it's going to pass through directly, and then it's going to bend to follow the asymptote forever. So it did cross the asymptote here. Hey, we know, right, that horizontal asymptotes can be crossed. So there it is. Now your next step obviously is going to be desmos.com, right? And you are going to check your graph and make sure that you did this correctly. So that was an overview of chapter 2. Depending on what you guys discuss in the announcements, let me just check. I'm going to refresh this real quick. I want to see if some of you already posted. Oh yeah, you guys are not joking. So April 15th, that's 2 weeks. That's not next week. I mean, I can't care less. By that time, we'll have about half of the chapter 3 done, because we'll do 3.1 on, 3.1 on Monday, 3.2 on Wednesday, 3.3. Yeah, we'll have at least 2 sections. That's, only 5 sections in chapter 3, so it goes quick. Anyway, discuss it. We'll figure it out. Put your best arguments. Remember that whatever you're writing here in chat is not staying for everyone to read in those discussions, so you have to retype. So yeah. Well, you asked for extra time. I don't want to disappoint you. So obviously I gave extra time. So it is already right there. So everyone, please discuss. Oh, you can't type in Canvas? That makes no sense. If you can't type in Canvas, you have to contact them and figure out. Actually, RVCC should be also dealing with that. You need to be able to. I already have people replying, and they've been replying for the last 2 weeks. So I know the feature is okay. It's a you issue, right? So you need to talk to the tech gurus over there and wizards to figure out what the issue is. All right, cool. Well, that's it for today. We had this overview and we solved some of the problems. Depending on the outcome of your discussions on Monday, it's either going to be a review or it's going to be 3.1. Now is the time to keep checking my MATLAB every day, because The quizzes might start tomorrow. They might start on, again, depends on what you discuss today. The quizzes might start tomorrow, or they might start in 2 days or 3 days, depending on where the date is. So keep checking my MATLAB every day. Bye.